Hello mathematicians. This little section is just about putting ideas together. So it's about exact values, so it means that our calculator is pretty useless for us here. And it's about being given one trig function, find another. So that will require us to put together several things. So the first thing is our knowledge that all the trig ratios are positive in this quadrant, only sine in this quadrant, only tan in this quadrant, and only cos in this quadrant. And the second is our interpretation of what it means to take angles greater than 90 degrees. So let's have a little look at these, and we'll just look at them for one ratio. So let's use the sine ratio. So suppose I'm trying to discover something about sine of theta. If theta is in this quadrant, so here's our angle theta, then we know it will be a positive ratio, and it's just the y-coordinate over the radius of the circle, if we're looking at our unit circle. If I go into the second quadrant, so this is now the angle theta, then I make use of the fact that in this second quadrant, sine of 180 minus theta, in other words, the angle in here to the horizontal, is equal to sine theta. And that comes from our definition, because in this second quadrant, sine of 180 minus theta is again y over the radius of the unit circle. If I go into the third quadrant with my theta, then sine of 180 plus theta works out to be minus sine theta, because in this third quadrant the y value is negative, the ratio is unchanged, and theta, the angle to the horizontal, is this little bit. And finally, if I go right around here into the fourth quadrant, so that I am theta short of the horizontal, so that the angle relative to the horizontal is 360 minus theta, then that works out to be, again, minus sine theta, because the y-coordinate is minus, and the radius is again positive. So sine of 360 minus theta is equivalent to minus sine theta. So we're just using this fact, and this has taken a long time to say that, but essentially, if we want sine of an angle in any quadrant, we find the sine of the angle relative to the horizontal, and we just notice what the polarity is. Is it positive or negative in that quadrant? Now, just have a quick look at one of these, and then the second one, and we'll move on. So let's say we're going to have a look at C. So in C, we're talking about an angle which is this big, that's theta, but we work on the angle 180 plus theta. So that's this value in here, or alpha, I think it's called in this question. We use Pythagoras, so this distance is 3 and it's in the negative direction. By Pythagoras, this distance here would be 4 and it's in the negative direction, and the radius of the circle is 5. So once we've established all that, we just see that sine of alpha is y over the radius, so minus 3 on 5, negative as we expect. Cos of alpha is negative 4 on 5, negative as we expect. Tan of alpha is sine over cos, which is either from this bit, negative 3 on 5 on negative 4 on 5, which is positive 3 on 4, or from this part, it's negative 3 over negative 4, which is positive 3 on 4. And again, positive as we expect. Our next example. Cos of alpha equals 4 on 5, and that's a positive. So that means that it must be in this quadrant or this quadrant. Sine of alpha is less than 0, it's a negative. So what quadrant are we talking about? Where cos is positive and sine is negative, it's the fourth quadrant. So we have to find tan of alpha. So that means we look at a triangle in the fourth quadrant, where alpha will be this angle, there's our right angle. Cos is 4 on 5, so cos is adjacent over hypotenuse. And by Pythagoras we can see that this will be 3, and it's negative 3. So tan of alpha is the opposite over the adjacent, which is minus 3 over 4. And, as we expect, it's negative because only cos is positive in this quadrant.